Okay, so this is 13.5 continued. So here's a generalization of theorem 10. We're not going to prove it, but it says if z equals function of x and y, x a function of s and t, y also a function of s and t, and all the partial derivatives exist, then a chain rule can be written like this. So you can see this extends theorem 10. In theorem 10, both x and y were functions of t only. This time they're functions of s and t. So it looks similar to theorem 10. Okay, so let's look at an example using this. So over here, it's practice quiz 5, number 3. So it says find the partial derivative of z with respect to t when t is 1 and s is minus 2. And here's our function. It's z equal to x squared y plus 2y, x equal 2st plus s squared, y equals s over t. We can write this guy as s t to the minus 1. So by the chain rule, so we're looking for partial z with respect to t. So you can't see it over here, but it's going to it's going to be f derivative with respect to x, partial x respect to t, plus fy partial y with respect to t. Okay, so note fx, partial derivative of f with respect to x. Here's my x here. So treating x as a variable, y as a constant, so it's going to be 2xy. Okay, y, so treating x now as a constant, it's going to be x squared plus 2. Okay, and the partial derivative of x with respect to t. Well, here's my x here, taking derivative with respect to t, so t is the variable, s is the constant, so it's going to be, so derivative with respect to t will be 2s here. And partial y with respect to t. So here's my y guy here, so you take the minus 1 in front. So the s, subtract 1 to the minus 2. So then plugging in up here our values we found. So the fx guy, which is this, that's going to go here. Fy is this, will go here. Partial x with respect to t goes here. Partial y with respect to t goes here. So making those substitutions, so the 2xy times partial x with respect to t, so times 2s plus fy, so the x squared plus 2 times dy dt, which is negative s t to the minus 2. Okay? So now, when say our t is 1 and s is minus 2, we have, so our x then, well, our x is, where is it? Oh, right here. So we're going to put 1 in place of t, negative 2 in place of s. So it'll be 2 times s minus 2 times t 1 plus s squared minus 2 squared. Okay, so let's go over here a bit more. So simplifying that, That's going to be negative, so it's likely it's going to be 0 for this guy. And y, so the y was s over t, so putting negative 2 in place of s, be minus 2 over t1, so it'll be minus 2. All right, so therefore, lastly here we'll have then partial z respect to t. So in place of x now we can put 0 here and here. In place of y we could put in minus 2 here. And in place of t we can put in minus 1 here. And in place of s we can put in minus 2 here and here. So doing that would be 2 times x, so x is 0, times y, which is minus 2, times 2s, s is minus 2, plus x squared, x is 0, plus 2, times minus s, s is minus 2, so minus minus 2, times t, so t is 1, t to the minus 2. So like that. Okay, so this whole guy here is 0. And I'll be positive 2 there, and 1 to the minus 2 power is 1, so the whole thing is going to end up being 4 as our answer. Yeah. Okay, so we're done.